Engineering students from the University of South Florida traveled to Delft in the Netherlands over the course of 3 summers, learning about water and coastal defense systems. The National Science Foundation program called IRES, or International Research Experience for Students, encourages global awareness and competitiveness for American students. USF was awarded the program back in 2009 and has sent 18 students to study at UNESCO-IHE, the Institute for Water Education.
Specifically, we're looking at applying technologies to generate clean water for drinking purposes and also cleaning wastewater. And we're also looking at technologies to harvest resources that we can harvest from wastewater.
USF engineering professor Daniel IHE is leading the research team in the quest for water management and water education that can be applied to developing countries.
For the PhD students, what they're working on was related to their research at USF, and the idea was to use the international experience working at IHE to enhance their doctoral dissertation. For the undergraduate students who are just getting going with research, there tends to be more flexibility. So a lot of the research topics were also very much driven by our partner over there in terms of their needs.
The IRES program is a knowledge exchange and offers perspective on climate adaptation. Drinking water treatment or removal of heavy metals, natural systems to clean wastewater, and engineered systems to clean wastewater were the main topics of research.
For a few students, though, they actually help IHE launch new research directions. We had a couple students who work on the anaerobic membrane bioreactor. That's something that IHE was not doing before we went over there, so we helped them develop that capability over there.
We were each paired with a PhD student. My PhD student was named Mr. Mike Achampong, and he is originally from Ghana.
Anton Dabchik was a part of the 2011 research team. His project experimented with natural filtration for water contamination in Ghana from gold mine runoff.
And a lot of people in Ghana draw their drinking water, cooking water, bathing water directly from these natural systems, which has been compromised by all of this gold mine discharge.
They used ground coconut shells as a filter for the heavy metals.
And it turns out that coconut shell sorbs copper up to a 98% efficiency. So water that's coming in 10 milligrams per liter, which is typical for Ghana, exits at about 0.2 milligrams per liter with a very low time to react, very low cost, and so it's a very robust system.
In addition to research, education and culture were part of the international experience. Students gained insight in and out of the lab at UNESCO-IHE.
A big part of what they were able to pick up was their Dutch approach and attitude towards climate change, especially climate adaptation.
The perspective that you gain from living in another place, especially for an extended period of time, is just unbelievable. They're extremely conscious of the situation that they're in regarding the fact that they're under sea level. Water is a big concern in the Netherlands. Everybody seems to be tuned in.
Climate adaptation is something that we're just starting to talk about here in the United States. In the Netherlands, they've been basically working on that for quite a while now. It's on the level that it's institutionalized a national policy.
The students attended meetings with the Dutch Water Board to observe how decisions are made on a small-scale community level. They listened in as Dutch officials explained their approach to flood defense and coastal safety. Much of the Netherlands is below sea level, and modern Dutch society has been shaped by the events following a devastating flood in 1953.
Most of the flooding happened in the southwest part of the country in the province called Zeeland, or Sealand. So through that event, they said, well, we're not going to let this happen again, so we need to build this system of interlocking coastal defense structures known as the Delta Works to basically close off our entire coastline from the North Sea if we need to.
The Water Museum in Zeeland offered perspective into the massive scale of the coastal defense systems that the Dutch have been working on for almost 60 years.
Over the next few decades, they embarked on some very ambitious, highly innovative public works on a massive scale. And a lot of these barriers were built unlike what you would see anywhere else in the world.
Students toured the port of Rotterdam to see how the city is preparing for the threat of climate change in the future.
There's water coming from the North Sea because of storms that might be associated with climate change. The front side of the city is protected by this very large storm surge barrier system. It's called the Maaslandkering storm surge barrier. It's basically the largest structure, moving structure in the world.
Other ideas that the Dutch are implementing for climate adaptation are a lesson in versatility, ranging from floating structures to green roofs.
So the city is really looking at some very innovative ways to increase water storage and flood protection.
The groups joined the Florida Earth Foundation for the tours through the Netherlands, giving them the opportunity to see these major hydrology feats. One stop on the tour were the windmills at Kinderdijk outside Rotterdam.
In the old days, they used to use these windmills to basically transport water up certain canals in order to basically drain the land, and then the land could be fit for farming.
A big part of the cultural transformation was learning to travel by different means and navigate without a car.
Fortunately, Delft is a city of bicycles. There are literally tens of thousands of bicycles in the city, and everybody's traveling around by bicycles. There are very well developed bicycle lanes.
Students also explored using the country's rail systems and water taxis.
There are very, very few cars, so the first thing I did when I got there is I bought a bike and just rode my bike to work every single day.
Discoveries during the 3-year research program include varied treatment methods and learning to combine engineering techniques to get the best outcome in different conditions.
But at the same time, they're looking at the newer approaches. Basically, it's a hybrid of engineer approach with nature, using nature as a very efficient, passive type of protection system. And sort of the new thinking now is that we really need to have engineered systems as well as natural systems working in harmony.
IHE says there are many similarities between the Netherlands and the state of Florida. Both rely on the sea and both are also vulnerable. He says we can learn from the Dutch approach to climate change by being proactive and taking certain steps now.
They were able to see some things that were either very difficult to implement or that we just haven't thought about implementing in the U.S. So they can now think about, well, how can we kind of apply some of these approaches back in the U.S.? What might be appropriate, what might not be appropriate.
For USF News, I'm Katie Hennig.